Or what I can do is I swap the presenter slides. So this will be the presenter slide. Okay, no, then you
Huh? No lah, don't do it. I think like that can, like that can, like that can, like that
Keep
can.
it this way.
Yeah.
Because I stand here now, I can't see the thing. So it's fine.
Yeah. Okay, can.
No, make it, can you make it mirror?
mirror.
Yeah. Just make it mirror. No need presenter, yeah. Okay.
Okay. Akhilesh, you ready?
Yeah, recording.
You just ding me at 8 minutes and I'm fine. Don't need 5 minutes.
Are we asking the questions after that also?
You need. I don't think you need practice Q&A. This is just more for Nick to visualize.
Yeah.
So the previous time when we ding you, we were at the OODA loop at 8 minutes. And then
Okay.
you managed to wrap up in 3 minutes.
Okay.
So just like for this and also for the future one, like when the ding happens, see whether you are at the OODA loop. If you're far from the OODA loop, then try to
Have to
speed
speed
up.
up lah.
If you're already at the OODA loop, then
Can talk
okay
more.
lah. Not more because you want
Can
to
just press
you
the
want
back
to,
button
You want to make sure you
on the
end,
on the road. Just.
you want
go
to
ahead,
end
go
with the family one or the thank you one by the thing.
Okay. True.
Yeah.
Okay, then I only let you know at 8 minutes.
Yeah.
Yeah, can. Ready to record. All recording already.
Recording already, yeah?
Actually, you can show him the time because he will also be able to see the time.
Okay, lor.
Yeah.
Yeah.
I mean, it's
difference
okay
is
lah.
that like I don't want him to speed up because he sees the timing is going up. So you can just flip the phone around. Because
Okay.
in the real one, he will also be able to see the
Okay,
time.
we'll see the timer. Okay. So, good morning everyone. We are Team Northeast and today we are excited to share with you our answer for this innovation challenge, which is the Causal Effect Traffic Assistance Generative AI app. So let me start with a question. How many of you have been stuck in traffic before? I'm sure everyone has, right? Does anyone want to take a guess how long each of us spent in traffic in Singapore in 1 year? Any guesses?
65.
How do you know that? It's actually 65 hours. And yes, most of you might be thinking, wow, 65 hours, that's a really, really long time. And I agree, what can you do in 65 hours? You could have a holiday in JB, you could even maybe make the LLM from scratch, just like this project. But, you know, what we want to do here, or what the LTA wants to do is to make sure that people like you and me get from point A to point B on time, most efficiently as possible, so we don't spend 65 hours stuck in traffic. And how they want to do this is by making optimal decision making and also making sure that the resources are deployed efficiently to make sure that incidences are resolved without matter. So how do we fit into this solution? So how do we fit into LTA's current solution is by augmenting their current capabilities with our app fitting into their current systems without taking out the human in the loop. So we are not really replacing anyone here. We're not trying to replace the ops center. We are just trying to make sure that the LTA's decision-making process is facilitated by using our application, which is more affectionately known as the CTAC app. So let's take a look at how the scenario flow would usually go inside the LTA ops center. So first, an incident happens. Then the key decision maker at the ops center will take their time to respond to the event and then deploy the resources, and after which the incident will be resolved. And based on our estimations, this takes roughly about 25 minutes. Now, let's take a look at what happens when we put our model into LTA's current capabilities. So when the incident happens, now decision-making time is cut shorter because of our model predictions giving suggestions to the ops center user and also allowing them to prime the resources for a faster deployment. And when the incident is resolved, we estimate this process to take about 15 minutes, giving you 40% time savings of this process. Now, what can you do with this 40% time savings? It spent about 10 minutes, right? Maybe you could get to your business meeting on time. Maybe you hear one less "Are we there yet?" from your kids and your partner, right? But I think we all know that this is a very common thing that we want to address, right? We want transport to be more efficient so we can get there on time. But let's take it one step further. What else does this time savings actually mean? Well, first, did you know that for every minute delay in someone receiving care after a serious injury, it actually decreases their chance of survival by 2%. So while for most of us, 10 minutes faster might mean I reached my restaurant reservation on time, or I reached to work on time, right? But for some of us, these 10 minutes might actually be very well the gap between life and death. And if we can get first responders to an incident 10 minutes faster, imagine the amount of impact that could make on someone's life. So in this case, this is where we develop our key principles, which are to save time, save resources, and most importantly, to save lives. And now this is quite a big and bold claim. right? How are we going to save resources and save lives? You want to know how we do it, right? How does it work? So let me go through the few use cases we foresee our application can fulfill. So first of all, we want to be able to extract out the hidden insights behind two incidents happening on the road. And this is our causal effect model. Okay? With this causal effect information, we can then, in the future, possibly even predict events using only one. We don't need two events, we just need one event, and with sufficient historical data, we can predict a future event from happening. And hopefully, further into the future, the most advanced development and iteration of our project will involve just taking situational data like weather, speed band data, and all of that, and possibly coming up with possible predictions of traffic incidences that might happen in the future. Right? And how we want to do this is with our step-by-step approach. Firstly, using data collection. So we use web scraping as our initial proof of concept, and then we use the DataMall API in order to fill our data set. Then, with our collected data, we employ traditional LLM techniques such as chain of thought prompting and retrieval augmented generation. Right? But with this, it's not enough in order to fulfill our use case for causal event detection and the other things we want to do with our project, which is why we decided to employ state-of-the-art advanced LLM techniques such as distillation LLM for our causal model, Raptor-RAG for a more reliable retrieval system, and we tie all of this together using the concept of multi-agents. So let's take a look behind the scenes into our model architecture and how multi-agents actually play a huge part in our application. So let's put ourselves in the shoes of Ops Center user, right? So as someone working in the LTA Ops Center, you will be directly interfacing with the master agent, and this master agent will be communicating with a few other sub-agents. First of all, being the causality agent, which I said earlier, which is enabled by our distillation LLM, and then the retrieval and suggestive agent, which is enabled by Raptor-RAG. And in the future, we want to further develop a multimodal agent in order to take in other data sources such as videos, and also to develop a predictive agent in order to complete our second and third iteration of our project in the future. Now, how does this all fit into a real-life solution? Let's take a look at our dashboard. So this is our CTech application dashboard, and how we envision our dashboard would look like inside the LTOC. Now let me walk you through, this seems like a lot, so let me walk you through the different features your screen is on. Yeah. So first, let's take a look at this. So our map will actually be visualizing the current events that are happening, and as you can see on the top left, it's actually an active alerts, which will be alerting the Ops Center user for any of the events that are detected by our model. If you look on the right, it's our data that we pulled from the DataMall API. And this data that we have will be fed into our causality distillation LLM. So our distillation LLM will be detecting causal event pairs, giving you the root cause of these events, as well as giving you possible future actions you can take in order to resolve these events. And on the right hand side of our distillation LLM is our Raptor-RAG retrieval system, which allows you to retrieve similar reports of events in the past in order to review best practices that you can do when this event happens. And after all of this, you'll be able to interact with the master agent through a chatbot in the event that the insights that you've received earlier are insufficient. And all of this comes together into a very comprehensive dashboard that we believe will be very useful to the LTOC. Now, you must be wondering now, how can this help you? So let me first introduce to you the concept of a OODA loop. So a OODA loop is a decision-making framework that's used in high-paced operation environments, such as in the army or even in medical emergencies. So currently, how we envision the process to be like in the LTOC, they will actually go through 3 different OODA loop thought iterations in order to go from start to finish and resolve an incident. However, with our CTech model, in the loop, we actually reduce the number of loops to 1 instead of 3. So this is 3 times making the decision-making process 3 times more efficient and saving more time. So from the first 2 OODA loops being eliminated, the person at the Ops Center just needs to focus on choosing the correct resolution to the incident, and executing it. And how much this whole solution will cost you, actually, we actually want to host it on Google Cloud, and this will cost about $130 a month, which actually works out to about $5 a day, which is, to me, really, really good. Right? So what do you get for $5 a day? Right? For $5 a day, maybe you get to go faster on the road. Point A to B, it's faster. Traffic is more efficient, right? And of course, another benefit we can see is that society as a whole becomes more productive because we're spending less time, we're not spending 65 hours in traffic anymore, right? And of course, everyone's favorite phrase, save time equals save money. And I'm sure this is already driving a very, very good case for our application. But beyond that, beyond just saving time, there's something that money can't buy. And it's something that all of us are actually a part of, which is when we travel on the road, we don't just want to get there fast, right? Something that we all keep in mind is that we want to get there safe as well. And something that money cannot buy is the smiles of your friends and family when you get home safe after your journey on the road. And that is what we are championing here at Team Northeast. We don't just want to sell a solution that makes travel more efficient, we want to sell a solution that makes travel more safe as well. Thank you for listening to our presentation. Yes, so now I invite my team up for a Q&A, and if you are interested to find out more about our application, you can actually scan the QR code at the bottom for a demo.
So we're about 10 seconds over. I think it's not.
But I think because the thank you already, so I think they will just